Thanks everybody for sticking around. I guess I'm the closer for the day here in the UD session. So I'll go through my slideshow here. I want to apologize in advance. There's a little bit of repetition here after what Hilda and Earl said and after what Abe said, but we'll work through it. So I work with the Massachusetts Alternative Septic System Test Center. We're part of the Barnstable County Department of Health and the Environment, and our primary focus at the test center is looking at IA septic systems, or enhanced innovative alternative septic systems. We've been doing that for 25 years. I've been at the test center now for about 3.5 years, and I think really kind of brought the interest in this alternative strategy of using eco-toilets as a means of nutrient management. So I've been sort of leading the charge for the county and the test center on this, and I'm really excited to be here talking about it. So again, I mentioned a little bit of repetition here, but make sure everybody's on the same page. So we know, the majority of nutrient pollution entering our waterways on Cape Cod is coming from our septic systems, our residential on-site septic systems. Not talking about IA systems, talking about conventional septic systems that are, basically designed to, capture our wastewater from our household usage and get it away from us as quickly as possible. They're designed basically to transfer the water that's produced in the house, the wastewater that's produced in the house, and to get it to the groundwater, basically. Put it in our sandy soils and get it to the groundwater. The problem with that, as we all know, we've been talking about it all day, is that the nutrients just pass right on through that system. When I say nutrients, I mean nitrogen and phosphorus primarily. And those nutrients readily travel through our sandy soils, hit our groundwater table, and then travel in one direction or another. So, I like to think of groundwater as like underground hills of water. And so there's a gradient to it, a slope, and the water will travel in whatever direction it's sloped towards. On Cape Cod, as you know, we're completely surrounded by the ocean and have like 800 or 1,000 ponds dotting the middle of it. So at some point, that nutrient, polluted wastewater is going to make its way to a water body, causing these harmful algal blooms like the picture on the right. So we've already talked about this a lot today too, but how do we deal with that on the Cape? We're looking at it on a watershed basis. So this shows all the different embayment watersheds of Cape Cod. And we mentioned that these don't necessarily follow town lines. So the way that resource managers are working on this problem here on the Cape is on a watershed by watershed basis. And the way that we're addressing that is through a whole variety of restoration actions. This is a little bit off topic on urine diversion, or quite a bit off topic on urine diversion here, but I just wanted to point out that once the nutrients make it into the watershed, they make it into freshwater ponds. At that point, we're basically using sort of Band-Aid solutions. Not to say that these are not good things to do in general, but once the nutrients have made it either into the groundwater or into a surface water like a lake, a pond, or a bay, treating it at that phase in the game, it's kind of like a little too late, So really what I'm here to talk about today is to promote source control. So trying to capture those nutrients, before they make it into the environment, for a whole variety of reasons. So our conventional approaches, again, we've been talking about this all day, are sort of conventional approaches of managing the nutrients that are produced in our wastewater are basically these two different options bulleted here. So we have municipal sewer systems. We can extend pipes out from a central treatment plant, extend one to every single house and every single business, anywhere that wastewater is produced, bring it to a central location and try to treat it there. So that's one strategy. The other strategy, like we focus on at the test center, is using these advanced or enhanced treatment IA septic systems. These are basically like miniature central treatment plants. They use the same process, the same microbes, and what they're doing is trying to microbially process the nitrogen and the phosphorus and put the nitrogen back into the atmosphere. The problem that I have with these approaches, and I'm not saying they're wrong or bad, they're one of the tools in the toolbox for dealing with the nutrient problems on the Cape, but the problem that I have with them is that they're part of sort of a linear nutrient management pathway. And what I mean by that is they're sort of missing the big picture. They're missing the sustainability aspect of the way that I think we need to live on the planet as humans. So basically the process is, we create fertilizers. We actually use a very large amount of energy globally to extract nitrogen from the atmosphere and to mine phosphorus from the ground, from the earth, to grow the food that we need to eat. We consume it, we excrete it, and then we expend quite a bit of money through wastewater management, using sewers, using IA septic systems to then get rid of those nutrients that we just spent a whole bunch of money and energy trying to get. And so, thinking about that, just you think it doesn't make a lot of sense, right? So there's this alternative idea that maybe we could somehow, take that linear pathway of nutrient management and close the loop. And so, this enters this strategy of what we call ecological sanitation or circular sanitation. I think describes it well. And this is my favorite quote that I think about every single day by R. Buckminster Fuller, that this pollution that we're experiencing is nothing but the resources we are not harvesting. We allow them to disperse because we've been ignorant of their value. And I really don't think that could be said any better for the situation that we're dealing with on the Cape here. So rather than expending the energy to get those nutrients and then expending the energy to throw them away, I think there are other ways to do this, and that's exactly what we're talking about in this session here today. So what I'm saying is these eco-toilets, both urine diverting and composting toilets and incinerating toilets, allow us to basically stop, curb the flow of nutrients from our bodies into the environment right at the source. And something I like to point out to people, and something that I had a realization a couple of years ago as I've worked in this field, is that when you're standing over the toilet bowl or the urinal and looking in there and about to do whatever you're about to do, I think it's really important to realize that that is pristine, clean, drinking quality water, and that is right there in the toilet bowl is it's a pollution point, right? It's a point source pollution, and I don't think we tend to think about that because we're so in society we just have accepted that that's an okay practice, and that's that's what we do. But I really try to stress that there are other ways, that we don't need water to go to the bathroom, to be totally blunt. The purpose of water in our sanitation systems is just to move the waste away. It's to transport it. It's not an essential human need to go to the bathroom and clean water. And so I think that's a really important concept to keep in mind, and something that I talk about every time I have the chance. So eco-toilets include composting, urine diverting, and incinerating toilets. One thing I like to point out too that I think is really important, that they're often more hygienic than water flush toilets. And a lot of people tend to think the opposite. When I'm talking to a newbie in the eco toilet world, a lot of times people say, "Oh, gross." I was talking to one woman at lunch, and she said very bluntly, "I'm not going to that talk. That's gross." We're standing in lunch. Maybe at lunch, is not the best time to be talking about this for some people. But people have this idea that eco toilets are gross. Go out and Google toilet plume, and you might start to think of something different. When you flush a water flush toilet, there's actually a plume of particulate aerosols that come up in the air in the bathroom, especially concerning in public facilities where there's a whole bunch of other people using them. Eco toilets typically don't have that. The waterless eco toilets, at least, there's no toilet plume, there's no water flush, there's no aerosols. And the other thing that makes them really hygienic and really nice to use is that most of them, especially composting toilets, have a negative air draw. So there's a fan that's venting the composting system. So all the air in the bathroom is actually going down the toilet bowl. That's how the bathroom is vented. So you couldn't make an odor in the bathroom if you wanted to in that situation. So I think it's has in most cases it can be a more hygienic experience. So the eco toilets divert the main source of nutrients in wastewater. They save a bunch of water. We've already heard a bit about that. The numbers from the Rich Earth Institute that I've heard is for every 5 gallons of urine diverted, we save 100 gallons of clean water. So that's pretty big. We conserve energy, like I mentioned, those sort of nutrient production and disposal pathways. We could eliminate that with the use of these toilets. And then they allow us the opportunity to recycle valuable nutrients. So composting toilets, we've seen a little bit about this today, but there's a whole variety. I'm just going to go really quickly through this. So, basically a composting toilet offers the opportunity to collect all urine and feces with either very little or no water usage. Let's see, there are many different toilet fixture options, and I think that's one of the important things to point out. I think the top right is what most people picture when they think of a composting toilet. And yes, there are, plenty of rustic, bucket-style toilets that people use that are composting toilets. But it's really important for people to know that there are actually other, very nice, very, normal-looking fixtures that are made out of shiny white porcelain. And so there's really a whole range of products available on the market that, I think would be acceptable in most of the houses on Cape Cod. Let's see, using these systems, you can produce compost, which is, valuable. You get a finished product this is actually legal in the state of Massachusetts. It's approved under the Title V Septic System Code that you can use a composting toilet. You can collect the material after it's been composted through that process, pathogens are destroyed. It reaches a high temperature, and then you can use that material as a soil amendment. Let's see, and I'm going to move on. I mentioned incinerating toilets. That's another type of eco-toilet. It's nice in that it's a source control, like I mentioned, right? You're not putting any nutrients into clean water and then disposing it to the environment. This is capturing all of the nutrients. In this case, you know, in my mind, a little bit of a downside, you know, you hit a button and you basically destroy those nutrients. You know, you're burning them up and using energy at the same time. But, you know, in certain instances where, you know, this is a good option, this is an option to avoid pollution at the source. These are actually pretty similar to the slides that Abe showed earlier, but there's basically two categories of urine diverting toilets. There are micro flush toilets that use a small amount of water, which is not ideal in terms of, you know, trying to recycle urine because it adds to the volume. You know, if you're adding a little bit of water to each flush, then your volume gets bigger. You might want to consider getting one of those freeze concentrating devices that Abe was showing. The alternative to a micro flush toilet is a waterless toilet. So, you know, waterless urinals, I think, like this place, you know, I've used the bathroom here today and I feel very guilty about it because those are water flush toilets. It would be very easy to swap those out for a waterless urinal that could be, you know, diverted into a collection chamber and then pumped out and recycled. So these are other examples of waterless urine diverting toilets. So the next thing I wanted to get to here is to share results of a couple of different projects that have happened on Cape Cod, you know, related to eco-toilets. So I think Hilda and Earl referred to this briefly during their talk, but in 2012, the town of Falmouth initiated what they called the Falmouth Eco-Toilet Project. They provided a financial incentive in the form of a subsidy to people that wanted to sign up and test out these systems and see basically, you know, how much nutrient removal they could achieve using these type of toilets. The study included a variety of different types of toilet fixtures. So some were just urine diverting, some were composting and urine diverting. So there's kind of a whole slew of different, you know, sort of technology combinations that were used in the study. And basically what they did was they sampled the septic tank effluent, so the raw wastewater that's leaving that household. They sampled that as a way of measuring the performance of these systems. And what they found was pretty staggering. You know, 80 to 90% nitrogen removal on average using these type of systems. And actually it's nitrogen and phosphorus. So the orange or the yellow lines are nitrogen and the white lines are phosphorus in that graph. And so we saw, you know, really, really high performance nutrient removal using these systems. A much more recent project just completed in the past year, working with folks at the Green Center, Hilda and Earl. They contracted with us at the Septic System Test Center to complete what we called the UD pilot project in Falmouth. Like I said, we just completed this last year. Hilda and Earl were able to get 41 different households to participate with about 60 people all together. They distributed these, you know, what I like to call informal urine diversion devices. These are called cubies. These are the ones that Abe showed that they develop at Rich Earth. So they distributed those to people. They got Board of Health approval in the town, and they had those people collect as much urine as they could using these devices over a 2-month period. And by the way, they filled these up many times during that 2-month period, so they had 55-gallon plastic drums either in garages or outside that they transferred the material into after collecting. And so it was my job to go out and measure the volume of urine collected in each one of those tanks, each one of those storage tanks, and to collect samples to measure the total nutrient content. And that was basically the purpose of the study, is to, you know, assess, you know, like one, it's kind of a participation study, right? How many people would be willing to do this? How often would they actually use the device? And then how much, you know, material and nutrients could we collect? So what we found, I think I said it there, we collected a total of a little over 1,000 gallons with an average of 29 gallons per household. So this just shows the 41 households across the bottom and the total amount of urine collected per household. Kind of similar to some of the stuff that Abe was showing a little while ago. There's quite a variety here. You know, we had maybe a few households that were under 10 gallons after 2 months. But then we had the overachievers who were, you know, up making more than 50 gallons over a 2-month period. So quite a range, but an average of about 29 gallons per household in 2 months. Then we analyzed for nutrients. So these are the sample bottles that I actually brought out. We have total phosphorus, and then nitrate, nitrite, and TKN is added up for total nitrogen. So we analyzed total nitrogen and total phosphorus. And what we found was really impressive and pretty much what we expected. Urine is basically fertilizer. Okay, thank you. So the average nitrogen concentration was over 7,000 milligrams per liter. That's actually a little higher than they have in Vermont. So there's something different with us Cape Codders, that we have a little more nitrogen in our urine. Average phosphorus concentration is 469 milligrams per liter. Compared to raw wastewater, these are very high, very concentrated nutrient sources. Looking at the load, so the concentration times the volume, we came up with an average total nitrogen of 0.74 kilograms per household and total phosphorus of 0.05 kilograms per household, and that's in 2 months. So that shows the total nitrogen per household over the 2-month period. And what I think is really interesting about this study that we conducted is, if you compare this to the targeted watershed management, or the TMDL goals, the targets that we're looking for to reduce nutrients to watersheds, it's like on par with sewering. And so this is an example of a project that is proposed in the town of Falmouth. The green area up there with the number 1 on it is an area that's proposed to sewer 811 parcels. And in the plan, the town plan, they state that sewering those 811 parcels will remove about 2,890 kilograms of nitrogen. So I figured that was sort of a good thing to compare with, looking at the rate that we found with the Green Center project. So at that rate of urine diversion, using cubies in 41 homes, if we extrapolate that up, to a full year, so basically just multiply that number by 6 months, we did it for 2 months times 6 months, we found that the nitrogen removal rate would be 4.41 kilograms per year per household. Multiply that by 811 homes, and we actually have more nitrogen removal using urine diversion than we did for sewering. Obviously, that's impossible because sewering captures all the water from a household and urine diversion does not. So what this indicates is that sewering is based on models that use a lower nutrient content than what's actually present. So not saying that urine diversion will remove more than sewering, but what that says to me is that urine diversion can really play a serious role in meeting our watershed management goals. So what's the next step? So we completed that project last year. Currently, the Septic System Test Center, is working with the town of Falmouth, and we are looking to basically deploy this on a larger scale and look further into this, as to whether or not this is, a viable and basically, permittable is one of the more challenging components of this. But we're basically just assessing urine diversion and working with the MASSTC to try to get both approval and to get official nutrient credit. Because right now we could all divert our urine, but that wouldn't benefit the towns that are trying to meet those, those watershed targets. So what we need to do is work with DEP in order to get an actual credit assigned for urine diversion, so that the towns could actually then deploy this, like an IA septic system or like a sewer expansion project, or maybe even more comparable to something like putting oysters in the bay to try to extract nutrients in that way. But the data shows that urine diversion has a ton of potential. Urine is like the source of nutrients entering our wastewater, and so if we can figure out a way to divert it and we can work with our regulators to get credit for it, it really seems like there's a lot of potential here. So what we need to do that is basically we're following the approval process that DEP has set out for IA septic systems. So what we need, according to DEP, is at least 50 systems installed. So that's what my diagram shows there. A whole bunch of systems around Falmouth. We need 50 systems actually installed. We need 3 years of performance monitoring. And then we'll basically produce a report on what the findings are in terms of the amount of nutrients removed in urine and the amount of nutrients left in the septic tank effluent. And then hopefully DEP will work with us to give us credit. And someday the dream is that this will be actually in those watershed management plans that towns are making to help save the water quality and save energy and save money for everybody. So that's the goal. And then the last slide I have here, I just wanted to point out that at the Septic System Test Center, we're in the midst of some site expansion. We have like 4 new employees just in the past year. We're putting in a couple of new buildings. And in the process of that, we're actually going to be installing eco-toilets in all of our bathroom facilities. So we're getting rid of all of our conventional eco-toilets. We're trying to walk the walk here. We're going to be putting in composting toilets, waterless urinals, split bowl UD toilet, gray water gardens. We're going to put in a greenhouse where we can process our gray water year round. So we really want to be, be a site that people can come and visit. And I think one of the problems we're experiencing on the Cape right now, trying to talk about this with people, is that there's very few places to go see and test out and see what they look like, push buttons, flip the lid. The Green Center does offer that quite often. They have tours of their site, but in general, I really think there's a need for more demonstration installations. So come visit us in a year or so, and we'll be happy to show you our toilets. So that's all I had to say. Yep, thank you.
Measured or looked at methane being produced, or are you seeing it's more or less the same as the current methods that we have in place?
Yeah, it's a good question. It's not something I personally have experience with and can answer. I mean, I know in wastewater treatment processes, methane is emitted at times, but not something I have any good information to share on. Good question, though. Rob?
So, Brian, one thing you're going to need to think about, if you try to think about this on a municipal scale, is sort of the downstream end product limit. I know back about a decade ago, there's a group of us that got together and started talking about doing struvite and all this. There's a number of things, but there has to be a downstream solution for at a municipal scale, not just go dump it in your yard. Because though some people will do that in a very regulated way to make sure the plants uptake the nutrients, that's probably not going to be an acceptable solution to most people. So in addition to looking at the MASSTC Center, the front end in terms of the fixtures and the usage of the fixtures, I also encourage you to start to do the thought experiment on what's that downstream tail look like. So that a municipality can bolt into that and doesn't have to be innovating that aspect of it.
No, absolutely. It's a very overwhelming field to be in right now because everything is new. So we're trying to figure out the disposal, reuse pathways, the collection pathways, the storage, transportation. We're trying to kind of figure it all out at once. But we are definitely thinking about that. This picture shows the direct field application shot from Rich Earth. So I think that
in Vermont, where there's a lot of direct fields to be put on.
Right. I know Hilda and Earl, though, have done quite a bit of research in, trying to locate farmland and especially, non-edible, like hayfield farmland, and there's quite a bit, just over the bridge, so that's one option. I was actually talking with a cranberry farmer. I'm learning, cranberry farms are pretty heavily fertilized, and so, maybe, replacing those synthetic fertilizers with a urine-derived fertilizer is a possibility, although, I think food crops are not the best place to start, given the social stigma around this.
That's look at, because there was a conversation in addition to the struvite about do you actually make a bag granular fertilizer product from it? That then that's then marketable. You're going to have to think that tail out for the municipalities to really embrace this.
No, I appreciate your thought there. And the other one that Hilda and Earl pointed out earlier that I am a big fan of as well is co-composting. So like something like those big drum composters. I actually know the county is working on finding a location near the test center for a composting facility. So I'm really hoping I can, I've had initial conversations, broke the ice a little bit, but I'm hopeful that, maybe we can find a collaboration there to co-compost. Sorry, there's a bunch of questions here. You pick them.
A quick follow-up on that. There are so many golf courses.
Totally.
A use of this product. And really median strips down the highway.
Absolutely. Yeah, turf is our primary crop here on the Cape, right? It's turf grass.
So
I just want to say thank you to all of you who have presented, Bryan, Hilda, Earl, and Abe. I think Steve and I stumbled onto the Rich Earth website a few years ago and started attending their summits and reading their material, and then met the rest of you. And I think this is absolutely the way we need to go. My background is in medicine and public health, and the toilet plume comment by Bryan was a major player during the pandemic. They didn't like to publicize that a lot and get people panicking, but I think most of you know that a lot of sewer systems are tested to monitor all sorts of disease outbreaks. And so to me, the dry toilets, and gardeners, so urine diversion makes sense to me. I think that certain populations would be great to join in as early adopters, like the gardening communities. I do agree that you need to figure out what to do with the end product for those that aren't gardeners, but on the Rich Earth Summits, I think it was the city of Zurich, Switzerland, they do all their municipal landscape fertilizing with the urine they collect through not the entire city, but significant numbers of neighborhoods. So it can be a real circular economy at a rural center, but also at a city center. So anyway, I just wanted to thank you. I think it's been a real honor to work with all of you. Makes sense to me.
Thanks, Jane. Yeah, actually, that's we should put a plug for Rich Earth, too. They have their annual Urine Diversion Summit coming up in November. So if you're interested in this topic, definitely register for that. They have, both remote and in-person attendance. And it's a great summit with people from all around the world who are working on this.
I just have one more short comment. I wanted to thank, I have 3 student interns with me from Wellesley College who are here specifically to study eco-sanitation. They're here for an orientation visit for a few days. Mara is with us here in the audience, and they were interested enough to sign up for a 2-month study internship to learn more about this.
Awesome. Thank you, guys. Yeah.
So another quick question. Have you guys looked at maybe expanding this cactus further west, specifically like I know here, for example, water for farming is not the most pressing issue that farmers have, but you look at Colorado, for example, and that becomes a big question.
Yeah.
Thought about getting to bring into that market. Is that something?
I'm kind of limited to Barnstable County, so but it's a really good point, though. I mean, areas with water scarcity issues. I mean, it seems like this should be a no-brainer for them. I'm really surprised it's not, but that's a great point.
That's a good question, and so the urine diversion is good for, in some areas it's for water saving. In other areas it's for fertilizer. Like we talked to a person who owns Stonyfield yogurt and milk and all that, and for him the most important thing is the fertilizer, because the farmers have to make the milk and they spend more and more money on the fertilizers to get their crops, and it gets more and more expensive. So for him the most important part of this urine diversion is the fertilizer, and for people in Phoenix or in California it's the water saving, and here it's for water pollution. In some places it's for all 3. So it's urine diversion has many benefits all over the world.
Yes. Not only thinking about using it as a fertilizer for maybe parks in a more urban area, like on flowers and stuff like that, could be a use, but also sod farms that are trying to produce that grass and make it nice and green and give it to consumers on a quick scale and basis.
Yep.
I think that would also be a great market to look into. I don't know how many sod farms there are around here, but definitely in southern Maine, where my college is, there's a few around there too. But
Okay. Yeah, good input. Yeah.
I have a quick thing, because I think you said Falmouth people, but I thought that maybe people outside of Falmouth, are they going to be allowed?
Yeah. So for the study, so it gets a little complicated, but so we're working with the town of Falmouth to develop this 50 participant study in order to get the approval and the nutrient removal credit. But all the participants do not need to be in the town of Falmouth. Really anybody in the state of Massachusetts could participate in this project. The confusing part, or the challenging part, is that the town of Falmouth is looking at funding the project in Falmouth, and providing subsidies for installations and the cost of monitoring and all the sample analysis. And so people participating from other towns would need to find a different funding source, or maybe work with that particular town to see if they're interested in participating. We actually did just apply for a grant. Who knows if we're going to get it? But we're trying to find these alternative funding sources. But anybody can participate. It's just the funding issue. It's the challenge.